Welcome to this lesson. In this lesson, I will be explaining the structure, the design, and the function of a standard headlight circuit. To begin with, the function of the headlight circuit is to produce extra illumination in conditions that we refer to as poor visibility, especially at night. At night, we need additional light in order for us to see the road ahead. It is also a legal obligation that any vehicle which is used on the road, on public roads, should be equipped with a standard set of headlights that have a deep facility. That is, we should have a facility whereby we can reduce the brilliance of the lamps in order to prevent dazzling the other driver coming from the opposite direction. Coming to the structure of the headlight circuit, the components of the headlight circuit, they include the battery, of course, for the power supply. There is a headlight switch, which is a multi-stage switch. We've got two stages there. The first stage supplies the park lights in front, and the tail lights at the rear, and the number plate lamp. The second stage supplies the dip switch, and it is at the dip switch that the driver is going to select whether to use high beam or low beam, deep or flash, as sometimes we want to call it. The operating principle is simple here. Current flows from the battery to the headlight switch, which is a multi-stage switch, as I said a few moments ago. At the first stage of the headlight switch, we are connecting to the park tail lights, and at low, these lights should have a wattage of about 5 to 7 watts. And the park lights and tail lights are normally used at dawn or at dusk in order to improve the visibility of the car from all other directions for other road users. I sometimes refer to them as side marker lamps because they will give other road users the approximate dimensions of the vehicle so that they approach with caution. The second stage, when operated, will supply current to the dip switch. Then at the dip switch, the driver will then now select whether to switch on to high beam or low beam. We do have a headlamp which has got two filaments, as you can see. This symbol represents a double filament lamp. One of the filaments is for high beam, the other one is for low beam. The arrangement is the same on the other side. We do have two filaments in one lamp. And the two filaments are connected at separate terminals at the dip switch, and they are also separately fused. So current will flow from the headlight switch second stage into the dip switch, where a selection is made by the driver on whether to operate high beam or low beam, depending on what is happening on the road. When passing other road users, we use low beam. When just crossing in the road with no one coming from the opposite direction, we are on high beam. So knowledge of this structure, as is the usual case with all other systems, would help us to identify common causes of failure. And this would also help us to diagnose, that is, and come up with practical measures that we can do in order to fix a problem that we would have identified. For example, the common problems that normally arise where headlights are concerned is the failure of one beam on both sides. We are saying switch over to high beam, the headlamps go out. But you switch over to low beam, our headlamps are operating normally. This will obviously mean that all those components that normally serve that particular beam that has failed are the ones that are likely to blame. So we will just have a follow-up of those components. They include the dip switch itself. It may fail to connect onto a particular beam. They include the fuse of that particular beam which may have failed, or the filaments. Both filaments left and right would have been affected by a short circuit and would have blown. And in some cases, overcharging of the alternator may cause, especially the high beam filaments, to blow. So it could be a case of high charging rates. So check your charging system if you suspect the charging system is failing. We do have cases whereby headlights will fail in total all round. So those components that are likely to fail and cause total and complete failure of both beams should be checked. Like in this case, we do have the headlight switch second stage. It may not produce the output. The dip switch itself may fail on both high beam and low beam terminals. Both fuses may be blown, and probably all filaments in some cases may have blown. So we have to inspect our lamps in order to ensure that we do have lamps that are functional. So basically, this is what we need to know about the headlight circuit, and in order for us to be able to attend to problems that have which are part and parcel of the headlight circuit. We meet again next time.